Chennai. It's my absolute honor and privilege to welcome you to this 73-year-old institute, and with a very pertinent topic about e-vehicles and incentives to promote electrical vehicle mobility. So thank you very, very much that you've taken time from your busy schedule, and we are really looking forward to an enlightening session. Just want to appreciate the efforts of the department, particularly the head of the department and the entire team in bringing this pertinent webinar today. Thank you very much, Dr. Jhunjhunwala, once again on behalf of the college, and a very, very warm welcome. Thank you.
Thank you, Neha, and thank you, Milind.
Thank you.
I'm going to give you an overview of electric vehicles in India. I hope every student, including the first-year students, are able to understand what I'm saying. Interrupt me if you cannot understand. If need be, we will answer questions later on. I've already in the chat given my email ID. Anybody who wants my presentation has to write an email to me. I'll be willing to give it to you. So I'm going to talk about electric vehicles in India, an overview. Now, first of all, why is there so much interest in electric vehicles? The primary reason that there is so much interest is first, because 14 of the 20 most polluted cities in the world are in India. So the vehicles are polluting like anything. You know, Bombay is polluted, Chennai is polluted. Every city is highly polluted. And this IC engine vehicles, petrol vehicles are just polluting. We are amongst the worst affected in the world today. Number two, our import bill of the oil keeps on going up. This is a very old number that I've given you. Already, it's really, really bad. It has been going up, and it has become much worse today. And with $100 per barrel oil price, our import bill is going to break our back. Now, in this situation, what is the potential electric vehicles? The first important thing that all of you should understand, electric vehicles is 4 times as efficient as an internal combustion engine, which is a petrol vehicle. 4 times more energy efficient. That means it takes 4 times less electricity for going the same distance. So that is one big advantage. Then it has a very few moving parts, unlike IC engine vehicle, which has large number of moving parts, and therefore they keep failing and we have to keep replacing them. Electric vehicles are therefore far more rugged because very few moving parts. So basically the internal combustion engine or petrol engine have a basic efficiency of about 22 to 23%. That means 75% of the energy is wasted and only 22-23% is used. Whereas when you use electric vehicles and motor, we are talking about efficiency higher than 90%. And of course, no dependence on oil. So where is the problem? What are the challenges? Basically, for a petrol vehicle, we use a petrol tank. For electric vehicle, we have a container of electricity, and this container of electricity is a battery. And this battery, as compared to fuel tank, is about 8 to 10 times heavier. For the same range, if you want to put petrol for, let's say, 150 kilometers, and if you have a battery for 150 kilometers, battery will be about 8 to 10 times heavier. This battery drives up the costs, it drives up the size, and of course the weight. This is the primary problem. Basically, battery is far more heavier as compared to a petrol tank. So that is the critical problem. The second problem is, of course, batteries will require charging infrastructure. For petrol, there are petrol pumps. We need to build alternate charging infrastructure where batteries can be charged. The big problem is that batteries do not charge fast. A petrol can be filled in a vehicle in 3 minutes, and the vehicle can move out. Battery doesn't happen. Cost, setup, everything that has to be worried about. So this is what is called energy density, watt hour per kg. Watt hour is the measure of electricity. How much? So 1 kilowatt hour is 1,000 watt hour. That's a unit of electricity. For each watt hour per kg, if you see the lithium ion battery which we use today is here, the kilowatt hour per kg is very, very low. And it's about 200 to 300 watt hour per kg. And even in terms of volume, it is very, very high volume. Watt hour, kilowatt hour per liter is here. But for petrol, diesel is much, much higher, 12 to 15 times higher. It is that which creates a problem. So how do we really overcome that? Remember, there is a 4 times more energy efficient, but in terms of weight, size, and cost is so much higher. So energy density for a best battery today is about 300 watt hour per kg. Tomorrow it will become 400 watt hour per kg, but it's still much, much less than the energy density of a petrol. There are other versions like LFP battery, which is even worse. So how do you really overcome that? Higher energy density, of course, if I try to make it instead of 400 watt hour, 4,000 watt hour, then there is a higher safety concern. But safety concern was also very strongly there at one time with petrol. Petrol is the most inflammable fuel, and yet we learned how to handle it. Similarly, higher energy density can be handled. But today we are 400 watt hour per kg. To be able to compare with petrol, it has to go up by 9 times, 3,000 watt hour per kg. And the petrol energy density is, of course, 12,000 watt hour per kg, but it is a 4 times more energy efficient. So even if we reach 3,000, we get onto the par. So cost of battery, on the other hand, is inversely related to the energy density. Higher the energy density, lower the cost of the battery will be. And over the last 10 years, we have increased the energy density by almost 4 or 5 times. And correspondingly, we have reduced the cost by 6 or 7 times. But the process is still on. We have to further reduce the energy density. Higher energy density means you will use less material. And if you use less material, the cost will go down. This is what is happening. Year after year, the cost is going down because energy density is going up. And we need to do much more because we are still much worse than petrol. In the future, costs and charging time may come down. So we have 3 problems: cost, charging time, and size and weight. Cost and charging time will come down considerably. New batteries will come. Size and weight will continue to be a problem for a long time. The future battery will be lithium air, lithium metal, solid state lithium, even zinc air and aluminum air. All that will help us bring down the cost and charging time. It will not help us with size and weight. Size and weight today is 7 to 8 times lower. Tomorrow it will become higher. Tomorrow it will become 4 times higher, maybe 3 times higher, but coming to par will take a long time. Tomorrow, lithium-ion battery may be replaced by hydrogen fuel. Today, it is extremely costly. That can potentially match the petrol energy density. But there is no visibility. Will it take 10 years? Even in 10 years, whether we'll get there, we don't know. This is the challenge. But even with the existing size battery, existing weight battery, electric vehicles are becoming viable. And that's what I'm going to tell you. What is the world doing and what is India doing? The world looks at large vehicles. For example, Tesla vehicles or cars are $40,000, $50,000. $30,000 is already about 20 lakhs. In India, one looks at cars which are 5, 6 lakhs or even lower. The world focus is higher, large size vehicle, higher cost. They can afford to pay. The world focus is long range. They want to drive 300 to 500 kilometers before charging. In India, nobody drives 300 to 500 kilometers in a day. So we can look at slightly lower. World is looking at fast charging, 10 minutes to an hour. These are not, and that all that brings up puts the cost up. On the other hand, for India, the focus has to be affordability. India, if I look at the vehicles, I look at the vehicles in 1890, before the pandemic, we used to add about 30 million vehicles a year. Majority were two-wheelers, about 21, 22 were 2 million wheelers and three-wheelers. There are very few passenger cars and large vehicles. So our 80% of the vehicles are two-wheelers, 85% of vehicles are two-wheelers and three-wheelers. And our two-wheelers cost very low, 50,000 rupees, 70,000, sub $1,000. Our three-wheelers cost about 1.5, 2 lakhs. Our cars, also 85% of cars are affordable cars, which are costing less than 10%. Only a few cars are more than 10 lakhs. A few cars, premium cars, are similar to the global focus. Our focus is less. So what I'm trying to sort of say, India's EV strategy, therefore, focus on two-wheelers, three-wheelers, and small four-wheelers, which are affordable. For that, we can very quickly get there. It is in these vehicles, India needs to take leadership in these affordable vehicles. And they can fairly easily compete with internal combustion engine or petrol vehicles. Two-wheelers and three-wheelers are already, their price is similar to the petrol vehicles. And four-wheelers cost also will come down, and you will see 5 lakh, 7 lakh rupees petrol vehicle, four-wheelers also, cars also coming in the next 4 to 5 years. That is what India should really do. And premium two-wheelers are very few in number. Out of 30 million, 2%, only about few 100,000 are not even that, about maybe out of 30 million, maybe 1% would be 300,000. So about 500,000 cars are there. That can be premium vehicles, and we don't have to worry about that. But we have to focus on two-wheelers, three-wheelers, which are sold at very, very high volume every year. So, what is the way out? We have to reduce the electric vehicles cost in terms of energy per kilometer. Electric vehicles without battery today cost much less than a petrol vehicle. But when you add battery, the cost goes up. And because battery is like a petrol tank. That petrol tank costs practically nothing. It's a box of aluminum or steel, whereas a battery is very expensive. So what is the approach that India should do? Since battery is the dominant cost, focus on energy efficiency. How can I increase the energy efficiency with minimum energy? How can I get more kilometers? It's a basically kitna deti hai in a different terminology. Kilometers per liter, instead of liter per petrol, we'll have to talk in terms of kilometers per kilowatt hour of electricity. That will reduce the battery size and therefore the cost. So our focus has to be energy efficiency. If we can improve energy efficiency, we can reduce cost. And a lot of work has gone on in this area. For example, when we started about 5 years back, in a three-wheeler, the energy required, we required 80 watt-hour to drive 1 kilometer. Today, we can do at around 50, 55 watt-hour. And how do we get there? By better motors and controllers. So if we design better motors and controllers is all physics. If we design better motors and controller, we increase the energy efficiency and thereby reduce the cost. Better tire. If I do a better tire, which consumes less energy when it rolls, that helps in improving the energy efficiency. If I do a better aerodynamics of a vehicle, and aerodynamics is also, because as the vehicles move, it cuts through the air. The air provides the resistance. And if I do better aerodynamics so that air can smoothly flow around the vehicle, then my energy density can improve. And if I can, of course, lower the weight, if I don't use heavy materials, if I use lower end materials, then my energy efficiency can improve. And that is the task that has to be done. That's a task number one. The second, with all this, will require a battery, which if I didn't do this, a battery size would have been like this. But if I did this, then by 35 to 40% reduction in improving the energy efficiency, I reduce the battery size. To that extent, my cost goes down. And a lot of work has been done in last 5 years to reduce this cost. What is the next thing that we can do? To make the vehicles even more affordable, after I have improved the energy density, normally use a battery size to give us large range, let's say 150 kilometers. Now, why can't I use smaller battery with, let's say, 50 kilometer range? If I use battery with 50 kilometer range, my battery size reduces by a factor of 3. My cost goes down like anything. The problem will be if I use smaller battery, then it will give me a smaller range. And if I use smaller range, then I have to charge very often. And a battery takes a long time to charge. Battery takes about 2 hours, 3 hours to charge. And after every 50 kilometers, I have to stop and charge for 2 to 3 hours. That will not be viable and nobody will like that. What if I use battery swapping instead? What if I use swapping? So suppose I buy the vehicle without battery and I hire the battery, just like you buy LPG gas cylinder. So the battery that I will use is charged battery. And once I run out of the battery, I go to one of the shops, give that battery. So suppose there is a chain of shops or chain of petrol pumps. Suppose I go to BPCL petrol pumps. I pick up the first battery and I use it. Whenever my battery runs out, I go to any BPCL petrol pump, give the battery, their battery away and take a charged battery. That can actually be done in 2 to 3 minutes. Then I don't have to worry about charging. And I don't have to own the battery. I have to actually only pay for usage of the battery. I don't have to pay upfront for the battery. Then the cost goes down like anything. There is another advantage. Normally our temperatures in India can go up to 45 degrees centigrade. If I ever have to charge a battery at that high temperature, battery gets destroyed. Battery behave best at 25 degrees centigrade. I should not charge the battery at 45 degrees centigrade. If I swap the battery, I have taken the battery and gone away. The BPCL, which takes the discharged battery, now can take it to air-conditioned environment and charge it at 25 degrees centigrade. If they charge at 25 degrees centigrade, battery life will increase. So this swapping can significantly reduce the cost. I call this BPCL as an energy operator who provides me battery on demand. If I use that, my one-time cost of the vehicle goes lower than that of a petrol vehicle. And I have to only pay for using of battery, which is for my 50 kilometers usage, I will pay so much. That cost can be comparable or lower than the petrol cost. That will work quite well. And I can then scale the electric vehicles very, very rapidly. Because my operation cost per rupee per kilometer, including battery hiring cost, is less than that for petrol, diesel, and CNG. This is something that India can do. So this is good enough for, so that means every 50 kilometers I am replacing the battery, which is good for an auto, good for probably for a taxi. Taxi, I may make it 100 kilometers, but it's not good for my personal vehicle. If I'm owning a two-wheeler or a three-wheeler, and if you tell me every 50 kilometers I have to run to a equivalent of petrol pump to change the battery, I don't like that. Therefore, Tesla or others design a vehicle for 500 kilometers, but then of course they cost 40 lakhs. What do we do in India? We have to use alternate approach. If I have to wait for charging, that takes a long time. Even fast charging takes 45 to 60 minutes. So that is not the approach. What if I design my vehicle with two batteries, small battery? For two-wheeler, 50 plus 50 kilometers. For a four-wheelers, for a car, 100 kilometers per 100 kilometers. Now, most of them in my two-wheeler, I don't travel more than 50 kilometers. In a car, I don't travel more than 100 kilometers. So if I charge it overnight, my one battery I will own, one battery I will hire on demand. So if I overnight charge my vehicle, then most days, 95% of the days, I don't have to even worry because I don't travel more than 100 kilometers. Typical day, I travel 30, 40 kilometers. So that is good enough. Even if I travel 70 kilometers, that is good enough. The day I need to travel longer in my car, I will go to a BPCL and take the second battery. Only for that day, I will take the second battery. Now I have 100 kilometers plus 100 kilometers. Even if I have to go from Chennai to Bangalore, I can take that second battery and start traveling. Now, I would have finished my 100 kilometers and then I will use, or in first I'll use my swappable battery. So if I've got 150 kilometers and my swappable battery that I had borrowed, that has run out, I will stop probably for a cup of tea or something like that. That time my swappable battery, I will stop at a BPCL petrol pump. It will remove my battery and replace that. Now I can travel another 100 kilometers. So swapping enables me to go long distance. From the day I need to travel long distance, even for two-wheeler, I can do that. Most of the days, I don't even need this extra battery. And I'll just charge overnight and use it. This will really help in our country, things to flourish. Of course, the third option for the people who have a lot of money is to take large battery, and then most days they still travel small distance, so overnight charging is enough. But the day they need to travel longer, they can charge. But if they already have 250 kilometers, they probably won't have to charge that often. So that will cost high, but let those who can afford to do that. The question is, where do you charge the vehicles? The best place to charge the vehicle is at your home. Overnight charging, because batteries like slow charging at low temperature. Nighttime, the temperature goes down and you can charge that. A simple plug. I own an electric vehicle for 3.5 years. What I do is overnight I charge in the night time, and that is good enough. It gives me a range of 110 kilometers. That's good enough. At public places, petrol pumps are not good places to charge, because petrol pumps, people go to fill up the petrol and get out in about 3 minutes. They don't like to keep the vehicle for about an hour, 45 minutes, which is what it will take to charge, even if you do fast charge. And slow charge will take 2 to 3 hours. So what are the better places? Parking lot. I come and park it at my college or at my office or in shopping centers or cinema hall. Then I can charge for 2 to 3 hours. Petrol pump is not a good place to charge. And I don't know why government does not understand. Government thinks that petrol pumps are a good place to charge. They are making a mistake. So all these three things can be done. Do we need standardization for charger? Yes, we need some standardization. Our charging plug has to be standardized. Connectors has to be standardized. the voltage has to be standardized. And then batteries need to talk to the vehicle. That needs to be standardized. Batteries need to the charger. That needs to be standard. Those are all communication protocols. That needs to be charger standardization required. Plug and voltage is pretty much what you need, and communication protocols. Fairly simple to standardize. Unfortunately, we are not doing a good job on that. But certain protection, minimum protection needs to be there. That is what needs to be done. So, what is a slow charge and a fast charge? There is a lot of confusion. If I have a small battery, let's say 5 kilowatt hour, and I charge it at 1 kilowatt or 2 kilowatt, it's a slow charge because it will take you 2 to 3 hours. But if I have a 1 kilowatt hour battery and I charge with 2 kilowatt, then it's a fast charge. So it is not the charger which is a fast charge or a slow charge. It is the battery in my vehicle which makes it a charger as a fast charge or a slow charge. Remember, slow charge and lower temperature charge is always good for a battery. Fast charge is not good for a battery. Fast charge hurts the battery, and the battery's life gets reduced. Every 1.5 years to replace the battery, in which case your cost will go very, very high. Most of our power plants are operating at 50-55% capacity. So we really don't have that problem. Certain grids, certain places grid may have problem that can easily be strengthened. And I think that's pretty much what I will like to talk about. I have a question that is often asked. If we move from petrol vehicles to electric vehicles, petrol vehicles today, the auto sector has 7.1% GDP. And our fuel processing and distribution is 5% of GDP. So are we going to lose jobs? Are we going to lose GDP? And most of you should be very concerned. Therefore, if we do this, are we going to lose so much of jobs? We will lose jobs if we import everything. But if we design every subsystem in India and manufacture them, if we design batteries plus cells, plus materials, motors, controllers, charger, power converters, vehicle management system, we will certainly not lose jobs and GDP. In fact, we will be higher than 12.1% GDP, plus the electricity generation. So in fact, we can increase GDP provided we do all these things. And what does it require? It requires, for example, battery pack design. First thing that we should design is battery pack. What is involved in battery pack design? Thermal design. And this is something that can be taught to a BSc and MSc student. Today there are packages. How to design thermal. Battery, when it is used, will generate heat. How does the heat flows within the battery? Will they be able to withstand 45 degrees centigrade? The mechanical design. Battery consists of lots of individual cells and parts. When the vehicles are moved, battery is going to shake. And when battery is going to shake, the individual cells are going to vibrate. Is that going to result into hurting the battery? How do you design such that the vibration is minimized? How do you do electrical design such that the current flows are even and does not result into large losses, does not generate too much heat? How to design a battery management system to get the best out of each cell? And how do you design to make the battery safe? All these are very much doable, at least at MSc level, if not at BSc level. This is something Indians are picking up very quickly, and this is something Indians can do. And in a short time, you'll find all these battery packs are made as per Indian condition in India. Cell manufacturing, it's like a chemical plant. This changes, the technology changes every 2 years. That's what brings down the cost of the batteries. This requires large plants, like the kind of plants which we have for petrochemicals and other chemical industry. And this is something now there are incentives provided by the government to set up. So we will set up these cell plants. And once we do that, that will employ a large number of people. The next is battery material. Unfortunately, all these battery materials are imported today. And this is the next thing that we have to worry about. As I told you, battery pack manufacturing, it has hundreds of individual parts. Each of these parts can be made. In any, for example, around Pune, all these parts are made. Around Chennai, all these parts are made. If we start making these parts, GDP will go up. Then the materials for batteries. Materials for batteries are lithium, cobalt, manganese, cobalt, and nickel and graphite. All these materials that we do not have. So if we import all these materials, of course, our import bill will go up like anything. But we can recycle used battery. We all use cell phones. 300 million cell phones get obsolete every year. The battery in that is thrown out. If we recycle these batteries, we can recover lithium, cobalt, manganese, nickel, and graphite. If we recover these batteries, and today technology is available for recovering that, and if we reuse these materials, then 90 to 95% materials can be reused, and we don't have to import. This is the strategy for India, and this is what India needs to do. It will create large employment. And then motors. We need large number of different motors. Today we import most of these motors, either from Germany or from China. But each of these parts are designable in India and manufacturable in India. If you do this, we will increase the GDP. And same thing that I can say for chargers. Chargers is another thing that we need to design and develop in India. If we do that, we will increase our GDP and increase the number of jobs. To conclude, I say it is possible for young students by the time you graduate to learn enough. There is no magic in all this. To design and develop every subsystem of two-wheeler and three-wheelers and four-wheelers. And we have to make these electric vehicles affordable in India. Otherwise, our pollution is too high, our import bill is too high. Already two-wheelers and three-wheelers are affordable in India. They compete well with the IC engine vehicles. In the next few years, we'll replace them. As I told you, we need to design and develop every subsystem. Four-wheelers will happen in a few years. Time is of essence. If we continue to import things and not design and develop, we will be flooded with imports and India will be in trouble. This is what India needs to do. And we can certainly do this. And by 2030, most of our vehicles can become electric. I have some references, an article in IEEE, and there is a blog also in which I have written a lot. If you want access to this presentation and to these links, please write to me. I will write down my email in the chat box, and you can take it and write to me, and I will be able to share these things with you. I think I'll stop by first writing my email again in the chat box. I've written once. If any one of you want my presentation, please write to me and I will be happy to share my presentation. Otherwise, I'm now open to question and answer. Thank you very much.
Yes. Thank you so much, sir. Dear student, session is open for question and answer. If you have any question, yeah, you can ask.
Yeah, whoever wants to ask questions can now ask me questions.
Dear student, if you have any question, you can ask. Unmute and ask. Yes, Nilesh Raut, is there any question from your side? Okay. Sir, can I ask?
Please go ahead.
Yes, yes. Sir, can we see I personally like enter presentation, and this is related to electric vehicle. Can we make a hybrid, like some part will operate on solar energy, and in case of solar panel, generally silicon is used, and can we decrease the bandgap of energy of silicon, and using that we can enhance efficiency of solar energy, and we will some part will work on of a car or any vehicle work on solar, and some part will work on battery. This is my question.
So, Milind, today solar energy is the cheapest form of electricity in the country. We generate solar energy, electricity from solar at 2 rupees per kilometer, per kilowatt hour, which is lower than what we generate from coal. Coal is 3 rupees, 350. So solar is already very, very well developed technology. And there are solar panels being put everywhere in the country, and the electricity is being fed from the grid. Similarly, wind energy is very, very inexpensive. Over time, over the next 8 to 10 years, almost all the electricity will be coming from solar and wind. So, you know, it is not best that electric vehicle directly have solar, because the area available is very small. The cost will go up and we'll get very little electricity. It is best to use grid and feed solar energy in the grid and charge from that electricity to the vehicles. The directly on the rooftop of vehicles trying to put solar is at least 10 years away. It is best to feed the solar and wind energy, electricity in the grid, and from grid we should charge that. That's the best way.
Okay. Thank you so much, sir. Dear student, anyone question? Seema ma'am, then you can proceed for vote. Thanks. Seema madam? I think I will check, sir, chat box. Is there any question?
Hello,
Yes.
hello.
Go ahead,
Hello,
Seema.
sir.
Yes.
Excuse me, sir.
Yeah.
Yes, sir. I wanted to ask, as you said that the chemicals like lithium means we'll get it back. So will it be in pure form, or it would be contaminated or something?
We can purify that. We can recover almost pure form, and we can further purify them. The techniques exist. There is really no problem. We have set up a small plant here at IIT Madras Research Park. Any one of you, anytime visit Chennai, come, write to me and come and visit us. You will see all these things, electric vehicles being made, and recovery of materials from the used battery. Today we use cell phone battery. Tomorrow we'll use other batteries.
Sir, there is one question in chat box. Vehicle. So my question is, should we switch to EV or keep to existing IC vehicle, going and try and develop?
Let me read the question myself.
Okay. Yes.
The manufacturing process of EV are considered to be more environmentally degrading than manufacturing of IC vehicles. This is not true at all. The manufacturing of motors and controllers and batteries can become totally pollution free. So this is not true at all. These are the kind of myths that some people try to propagate. It is possible for us to 100% recycle everything that we need for electric vehicles.
Hello, sir.
Yes.
Sir, myself, Nilesh Raut. I want to ask
Nilesh.
that, sir, can supercapacitors replace the batteries?
Supercapacitor today is just nowhere compared to battery. Battery energy density, as I told you, is 350 watt-hour per kg, and still it costs quite a bit. Supercapacitor torque battery of same size will cost you 100 times more.
Okay.
And size will be much, much larger.
Okay. Okay.
We don't see supercapacitors even competing for a long time. I won't be able to answer what will happen 15, 20 years down the line, but the next 10 to 15 years, there is no chance. Whereas solid state battery, these batteries will evolve into solid state battery.
Okay. Okay, sir. Thank you.
Lithium polymer batteries, solid state batteries, all these are in research stage. They may take 5 to 7 years. Some of them may come. But you know, what does a battery cell look like? Battery cell looks like your cell phone. As far as we are concerned, one cell phone with one chemistry will be replaced by another cell phone with another chemistry. The battery pack making is more or less similar. Any other question? There is a lot of R&D. Question is, are there other battery technology? Lot of R&D is going on with lots of different batteries. For 5 to 7 years, there is no visibility of anybody, any other battery competing with lithium-ion batteries. After 7 years, I can't say. Any other question?
Sir, I will check in chat box.
No, on chat box, there is nothing. I'm watching the chat box.
Sir, just one question. Is it going
Yes,
to be
Namrata. Go ahead, Namrata.
yes, sir? Is it a completely 100% a green vehicle? Means no carbon emission or nothing is going to happen. It's
As long as energy is generated from solar to wind, the whole process is 100% green.
So
As long
only-
as electricity is generated from solar and wind, then it is fully green.
okay. So only constraint is going to be we are still going to depend on a fossil fuel, right, no, sir?
Should not. We should not. Today, I just now told you, electricity from solar and wind is cheaper than electricity from coal and petrol.
But we are going to depend on a lithium-ion battery. So battery material will be needed only, no, sir?
Yeah, but lithium-ion batteries can be recycled. No problem.
Okay. Thank you
Sir,
so much, sir.
yes, thank you, ma'am. There is one question from Danish in chat box.
Yes. You said that instead of fast charge, we should focus more on. No, you know, if you want to go long range, you can have fast charge, but your battery cost will go up because fast charge batteries are different from slow charge batteries. So yes, you can design a for Tata vehicle 200 kilometer range. Most of the days you will not travel more than 200 kilometers. Best is to charge slowly. Very occasionally, if you charge fast, it is okay. But it should be like 1 in 100 days, or 1 in 50 days, you charge fast, not more often than that. If you charge every day fast charge, battery life will go down like anything. Any other question?
Yes, there is one more question.
Can use rechargeable battery with solar cell to charge the battery? No, you see, if you use only solar cells to charge battery, then you can only charge in the daytime. And daytime you may be driving. Best is let the solar cells and wind electricity be fed to the grid, and you charge from the grid.
Yes, thank you so much, sir.
You know, so our grid should become in next 10 years 70% green. In 15 years, almost 90% green. That's a separate problem, but we should work on that.
Thank you so much, sir. Seema ma'am, you can proceed forward.
Thank you so much, sir. We really enlightened with your talk. It is so simple. First of all, I will really like the one thing that is you connected with the students so nicely. Otherwise, in a question answers, we always ask the student, please ask, please ask. But today's session, everybody is asking promptly the question, and that's the connect you have did with the students. Thank you so much, sir. It's really a nice session for us.
Thank you. There is one more question in the chat box. Can the development of carbon neutral
Yes, sir.
fuels be beneficial? I don't know what carbon neutral fuels are you talking about. Fossil fuels will always have a lot of carbon, and then we will keep on running. I don't understand why. We should just move to electric vehicles. Remember, even if you use fuels with less carbon, it is 4 times less efficient than electric vehicles. We should move to 4 times less. Why are we using for 1 kilometer so much energy? We should use less energy. For efficiency reason alone, we should move completely to electric vehicles. Sir, can EV batteries be recycled? Yes, it is being recycled. I'm doing it at Power Labs. As I told you, if you ever visit Chennai, visit us. In fact, there is another lab at IIT Bombay, Professor Sagar Mitra. He is one of the best person in the country on not on recycling, for making of batteries. He is not in recycling. Any other question? We have another 2 to 3 minutes, after which I have to drop out.
Yes, dear student, any question you can immediately ask within 1 minute.
You can even ask questions directly or in the chat box.
I will share
Sir,
a minute.
Sir, just one. Can I say something, sir?
Please go ahead.
Sir, just one kind request. After your lecture, so many students and even a faculty are really wanted to visit. So soon we are mostly visiting your institute. So please grant our visit to your institute.
No problem. You just write to me. I'm again writing my email ID, and we can certainly arrange a visit.
Is there any number constraint, sir, for the visit?
No, we will do it in batches. Don't worry.
Yes, sir. Thank you so much, sir.
How can we make an Indian customer believe to buy electric vehicles? This is a question from Nilesh Kohli. The electric vehicles are new. In next 2 to 3 years, every Indian consumer will start believing it. 2-wheeler, 3-wheeler already is happening. 4-wheeler will take a little more time. All right. I think with that, there is no other question. I suddenly see somebody else. No. All right. Fine. I think, Milind, can I get out?
Thank you so much. Thank you so much for your lecture.
Thank you.
Thank you.
And I am leaving.
Yes. Thank you. Thank you, dear Sean. Thank you all. Thank you so much.
Thank you so much, Milind, sir. Really
Thank
a
you.
nice speaker. Because of you, we really heard a very nice lecture. And really, we are going to plan this. So we have to plan this visit.